Hello guys, this is a past paper of March 2019, MCQs of AS. Question number 1. A wave has a frequency of 5 gigahertz. What is the period of the wave? Okay, frequency is given, so frequency is 5 gigahertz. Giga means 10 to power 9. So if you convert giga, it is 10 to power 9. So you know that time period is 1 over frequency. So 1 over 5 times 10 to power 9, which is 0.2 times 10 to power 9. If you write it, rewrite as 10 to power 12, it becomes 200 times 10 to power negative 12 seconds, which is 200 picosecond. So A is right. Question number 2. At temperatures close to 0 Kelvin, the specific heat capacity of a particular solid is given by C equal B times T cube, where T is the temperature and B is the constant characteristics of the solid. The SI unit of a specific heat capacity is joule kg negative 1 K negative 1. What is the unit of constant B expressed in SI base unit? We know that joule is not in it is in SI unit, but it is not base unit, so you should convert joule as well to base units. So we write equation C equal to B T cube. So B is the subject, equal to C over T cube. C is joule kg negative 1 K negative 1, as the question said, divided by Kelvin cube. Then we know that base unit of joule is kg meter square second negative 2, because W is F times D and F is MA. M is kg, ms negative 2 is A, times D is M. Unit of D is meter. So you can find kg m 2 s negative 2. So if you substitute joule kg m2 s negative 2 times kg negative 1 times k negative 1 divided by k 3. So the final result will be, if you simplify kg and kg negative 1, the final result will be m2 s negative 2 k negative 4. B is right. Question number 3. The speed of an aircraft in a still air is 200 km per hour. The wind blows from the west at a speed of 85 km per hour. In which direction must the pilot steer the aircraft in order to fly due north? Okay. So wind blows from the west at a speed of 85. So this is vector for wind. And a speed of aircraft in a still air is 200 km per hour. So what is resultant? Resultant will be x. Resultant will be x. So x will be perpendicular to 85 km per hour to the west. So north is perpendicular to the west. So this is x. So we know that if we consider theta, we can write sine theta equal to 85 divided by 200, opposite divided by hypotenuse. So if you use sine inverse by calculator, you will get 25.2. And the direction will be west of north. So D is right. So aircraft, in order to go to the north, must have an angle of 25.2 towards northwest. I mean to go straight to the north because of wind. So D is right. Question 4. A digital balance is used to weigh ingredients in a laboratory. When a weight is applied to the digital balance, an electronic circuit generates a current which is converted into a digital readout on the display. The electronic circuit gives a current of 2 milliamp when a weight of 30 Newton is applied, and a current of 0.5 milliamp when a weight of 5 Newton is applied. Which calibration curve could represent this circuit? First of all, we can say that B and D will be wrong. Why? Because when I is 2 milliamp, weight is 0 for B and D, which is wrong, because when I is 2, weight is 30 Newton. That's why B and D will be completely wrong. Now, between A and C, we can say which one is right. Between A and C, we can see that in A, gradient decreasing, and in C, gradient increasing. We have 2 points in the questions. We can find gradients when current is 0.5 milliamp and weight is 5. And we can see that 0.5 divided by 5 is more than 2 divided by 30. So it means C also is wrong, because in C gradient is increasing, but as we can see, when current increases, gradient decreases according to this inequality. So that's why A is right. So question 4, A is right. Question 5. 4 students measure a time interval that is known to be 1.704 seconds. The measurement recorded by each student is shown. Which measurement is the most accurate? We know that human reaction time is nearly 0.1 second. So we should record time to the nearest 0.1 second. Based on this, B is right. So question 5, B is right. Question 6. A mass on the end of a spring bounces up and down as shown. After being released at time t equals 0, now, which graph shows how the velocity varies with time? According to main figure, we can see that at this point, a speed or velocity is 0. So distance at this point, a speed is 0. So we can say that B wrong, and also B is wrong, and D will be wrong. Why? Because this is not oscillation graph for velocity. So B and D will be wrong. Now, between A and C, we should choose one of them. We know that in the main figure, a speed or velocity becomes 0 once. So between A and C, we should choose A, because A happened only once. So A is right. Question 7. A stone is thrown vertically upwards from a point that is 12 meters above the sea. It then falls into the sea below after 3.4 seconds. The resistance is negligible. At which speed was the stone released when it was thrown? Okay, in this question we want initial speed of a stone. Suppose that position you throw something up or down is origin. So below this point, y is negative. If you use motion equation, y equal to 1 over 2 at squared plus ut, then y become negative 12 meter. So if you substitute negative 12 meter equal to 1 over 2, also if you suppose upward is positive, downward will be negative. That's why g is negative, negative 9.81 times t is 3.4 square plus u is positive because it is upward, so it is positive, times 3.4. If you simplify, you will get 13.3 meter per second. So you can choose C if you round off 13.3 to 13. So 13 meter per second, C is right. So in this question, first of all, you should suppose one origin point, which is a point that you throw something up or down, and then you should consider direction of positive or negative. Then you can find sign of A and sign of Y as well. Question number 8. Two balls X and Y are moving towards each other with speeds of 5 and 15 respectively. They make a perfectly elastic head-on collision. So this part is important. Perfectly elastic head-on collision. So when collision is perfectly elastic head-on collision, then we can use relative speed of approach equal to relative speed of separation. So you can write relative speed of approach equal to relative speed of separation. Before I solve this question, I should tell you something about relative speed. For relative speed, if two objects move in opposite direction, we should add their speeds. If they come close to each other, or if they go away from each other, for relative speed, RS means relative speed. Abbreviation of relative speed, that I suppose that. RS means relative speed. So you should add speeds if they move in opposite direction. So in this situation, V1 plus V2. In this situation, V1 plus V2. If they move in one direction, then you have to subtract. This is for relative speed. You should use only for relative speed or relative quantities if you want to use it. Apart from speed, you can use that. Now, relative speed of approach, one of them is 15, one of them is 5. So 5 plus 15 equal relative speed of separation. One of them is 7, another one you don't have, then you can find answer easily. So a speed of ball X after collision will be 13 meters per second, and because it is positive, so to the left. So 13 to the left. And also you can say that a speed of X can be determined by the largest speed. For example, in this question, Y is 15 to the left. So a speed of X after collision will be to the larger speed. Larger speed is for Y to the left, so final speed will be 13 meters per second to the left because of larger speed before collision. So B is right. Question 9. In the absence of air resistance, a ball thrown horizontally from a tower with velocity v will land after time t seconds. If, however, air resistance is taken into account, which statement is correct? Okay. First of all, we know that air resistance force is always opposite to the motion. So time taken will be more than t. For velocity will be less because of air resistance force, which decrease velocity, which affect on velocity and decrease velocity. That's why A will be right. Question 9, A will be right. And the path for this projectile motion is parabola for this question. So path is parabola, and then the answer will be A. So question 9, the answer will be A. Question 10. Two balls of masses m and 2m traveling in a vacuum with initial velocities 2v and v respectively collide with each other head-on as shown. After the collision, the ball of mass m rebounds to the left with velocity v. What is the loss of kinetic energy in the collision? So, they collide to each other head-on. But in this question, it is not perfectly elastic. That's why kinetic energy is not conserved. But conservation of momentum will be true for every question in every matter. So conservation of momentum is always true, but conservation of kinetic energy will not be true if collision is not perfectly elastic. So for conservation of momentum, we can say that sum of the momentum before collision equal to sum of the momentum after collision. So mass 2m times v, so this is direction, so I suppose this direction is positive, so this right to the right will be negative. So 2m times v minus m times 2v, this is sum of the momentum before collision, and after collision we can write for mass m times v, because it is said that rebounds to the left, so m rebounds to the left, that's why v is positive for mass m. And for 2m, we don't know direction, that's why we should write positive, and then we can wait to get result. So 2m times v prime. V prime is a speed of 2m, or velocity of mass 2m after collision. So if you simplify, v prime become v over 2. If you simplify, v prime equal to v over 2. Okay, then write kinetic energy before collision, which is 1 over 2 times mass times velocity squared, So 1 over 2 times m times 2v squared plus 1 over 2 times 2m, because mass of second object is 2m, times v squared. This is kinetic energy before collision, which is 3m v squared. Now kinetic energy after collision. For one of them is 1 over 2m v squared for mass m, and for mass 2m, for object with mass 2m, 1 over 2 times 2m, and the velocity is v prime, you got before, so v over 2 squared. The result will be 3 over 4 mv squared. This is kinetic energy after collision. If you subtract these two kinetic energy before and after collision, you will get 9 over 4 mv squared. So C is right. Question 11. A ball falls through a liquid at a constant speed. It is acted upon by three forces: an upthrust, a drag force, and its weight. Which statement is correct? We know that when a speed is constant, weight is equal to upthrust force plus drag force. That's why B is wrong. So B is wrong. C also wrong. It is said the upthrust is constant with increasing depth. So this is also wrong. The weight is greater than the sum of the drag force and the upthrust. This is wrong, because as I said, when a speed is constant, weight is equal to upthrust plus drag force. So C, the upthrust is constant with increasing depth. So sorry, C is right. C is right. The drag force increases with increasing depth. So this is wrong. So in question 11, drag force increases with increasing depth. This is wrong, because it is at a speed constant. The drag force is equal to the sum of the upthrust and weight. This is also wrong, because weight is equal to upthrust plus drag force. And D will be wrong, as I said, when a speed is constant, weight is equal to upthrust plus drag force. So B also is wrong, and D also wrong, so C is right. Question 12. When a speed, in this question said a speed is constant, it is at a fairground ride consists of 4 carriages connected to a central vertical pole as shown in the following view from above. What is the question? The question said, which torque does the motor need to apply to the pole to keep the system rotating at constant maximum speed? So again, in this question, a speed will be constant. When a speed is constant and maximum, we know that in the air, when free fall for a body, when a body is falling, when the speed is constant, this speed is maximum and it is called terminal velocity. For this question, when a speed is constant, forwarding force equal to resistive force. That's why F minus friction force equal to MA, because a speed is constant, so MA is 0. So F equal to frictional force equal to 85, or resistive force equal to 85. Now, what is torque for this question? We know that there are 2 rods. For one of them, I can write F times distance between 2 forces, 2 parallel forces, which is 6.40, plus for another rod also F times 6.40. This is a torque for each rod. So F is 85, as we got from above explanation, times 6.40 plus 85 times 6.40. The result of total torque will be 1088 Newton meter, which if you round off will be 1090 Newton meter. So D is right. Question 13. A uniform horizontal beam OX 4 meter long and weighing 100 Newton is hinged at a wall at point O. It is supported by a cord XY which is attached to the wall at Y. What is the tension in the cord? Okay, we know that what is moment? Moment is force times perpendicular distance to the pivot. Because of that, we consider if this is tension, we need perpendicular to the rod. So this will be T sine theta, because we need angle of 90 for that. That's why it is T sine theta. So now it is said it is supported, so it is balanced. That's why clockwise moment, sum of the clockwise moment should be equal to sum of the anti-clockwise moment. And about beam, it is said uniform. When it is uniform, then we consider mass of beam in the middle of beam. So this is weight of beam which is in the middle of beam because it is said uniform. Now we consider O as a pivot. So you can write clockwise moment, sum of the clockwise moment equal to sum of the anti-clockwise moment. We have only one force clockwise, which is W, times distance to pivot, which is 2 meter, because the whole beam is 4 meter, equal to force T sine theta times distance to pivot is 4 meter. So W is given 100 Newton, T is not given, sine 30 times 4. We know that sine 30 is equal to 1 over 2. That's why you can find T if you simplify. Instead of sine 30, if you write 1 over 2, 1 over 2 times 4 becomes 2, 2 and 2 cancel out, and T will be 100 Newton. So D is right. Question 13, D is right. Question 14, an object shaped as a hemisphere rests with its flat surface on a table. The object has radius r and density rho. The volume of a sphere is 4 over 3 pi r cubed. Which average pressure does the object exert on the table? Okay. We know that pressure is force over cross-section area. Instead of force in this question, you can use weight of object, and instead of mass, because you know that density is mass over volume, so mass will be rho times V. You can use rho V times G. Then volume is half of the volume of a sphere. So 1 over 2, 4 over 3 pi r cube. Because it is hemisphere, so volume is half of the whole hemisphere volume, times by g divided by cross-section area of a hemisphere will be pi r square. So if you simplify, you can get 2 over 3 rho r g. So D is right. Question 14, D is right. Question 15, which statement best represents the principle of conservation of energy? We know that this question is very simple. C is right. The total energy in a closed system is constant. You must say in a closed system because no external force exerted on the system, then we can say conservation of energy is true. Okay, question 15, C is right. Question 16, a crane is being used to lift containers off a ship. One container has a mass of 14,000 kg and is being lifted vertically with a speed of 3.2 meters per second. The electric motor being used to supply the power to lift the container is using a current of 240 ampere at a potential difference of 2200 volt. What is the efficiency of the system? Okay, first of all, we should find useful power. You know that moving power formula is F times V. So P equal to, instead of F, you can write mg. So 14,000 times 9.81 times 3.2. So this is the useful power. What's the formula of efficiency? Efficiency equal to useful power divided by total power times 100%. So total power also equal to IV. So I is 240 and V is 2200 volt. So if you calculate, you can find efficiency. So efficiency will be 43 9040 divided by 52830 times 100%, which the final answer will be 83%. So D is right. Question 17. The data below are taken from the test of a petrol engine for a motor car. Power output, fuel consumption, energy, content of fuel are given. What is the ratio of power output divided by power input? Okay, first of all, power input. For power input, we can write 40 megajoules times by 20 because of fuel consumption divided by time, which is set per hour. So 1 hour is 60 minutes times 60 seconds, which is 3600. Okay, now what is the ratio of power output over power input. So for power output, you can say that power output is 150 kilowatt. So 150, instead of kilo, you can write 10 to the power 3 divided by power input, which is 40 times 20 times 10 to the power 6 divided by 60 times 60. If I cancel 60 and 60, and instead of 60 and 60 write 60 and 60, then B is right, because 60 and 60 can come and times in numerator. That's why you can write it in numerator, 60 times 60. So B is right. Question 18. Leonardo da Vinci proposed a flying machine that would work like a screw to lift the pilot into the air. The screw is rotated by the pilot. Okay. Which useful alpha power must the pilot provide to move vertically upwards at a constant speed of 2.5 meters per second? Because a speed is constant, so you can use moving power for this question. So moving power is equal to F times V. Instead of F, you can write mg. So m is 120, g is 9.81, and v is 2.5. So if you times, the answer will be 2940 watt. So if you round off, so D will be right. So it is nearly 2900 watts. Question 19. A metal wire fixed at one end has length L and cross-sectional area A. The wire extends a distance E when mass M is hung from the other end of the wire. What is an expression for the Young modulus E of the metal? We know that Young modulus is equal to a stress over a strain. S stress is force over area, and S strain is X over L, extension over original length. Instead of F, if you write mg, and extension, it is set E, then B is right. So question 19, B is right. Question 20, a spring has a spring constant of 6 Newton per centimeter. It is joined to another spring whose spring constant is 4. A load of 80 Newton is suspended from its composite spring. What is the extension of this composite spring? Okay, we know that 80 Newton applied to 4 and 6 as well. So you can write extension separately and then you can add them together. So Hooke's formula is F equal to Kx. So F is 80, K is 4. This is 20 centimeter x1, and also again you can write 80 equal to 6 times x2. So x2 will be 13.3 centimeters. So total extension will be x1 plus x2, which is 20 plus 13.3, which is 33.3. If you round off, it is nearly 33 centimeter, which D is right. Question 21. In question 21, in this question, it is said that what is the best estimate of the strain energy in the rubber when a load of 80 Newton is applied? So from 0 to 80 Newton, you can draw a straight line, find area under this straight line, which is W2. And then you can add with W1 to find, the best estimate of the strain energy. Because you know that when we have F, a graph of F extension, so the area under the graph shows a strain energy. Okay, so W2 equal to 1 over 2 F times X. What is F? 80, as the question said. And what is extension? 0.016. So the answer will be 0.64 joules. So this is W2. So the total strain energy will be W2 plus W1. W2 is 0.64 and W1, we don't know W1. But we can guess if W2 is 0.64, so D will be wrong because D is twice of this value, that's why D is wrong. A is wrong because it is less than 0.64, and B also is wrong because if you choose B, you don't consider W1. So the best answer will be C. So the best answer will be C for question 21. Question 22. A sound wave passed through air. The diagram shows the positions of the molecules of the air at one instant. Which distance is equal to the wavelength of the wave? We know that to find wavelength, we can use middle of rarefaction to middle of rarefaction, or middle of compression to middle of compression. So to find wavelength, you should choose PR or QS. In this question, we have QS. That's why D is right. So distance between middle of compression to the middle of next compression is called wavelength, or same definition from for rarefaction. Same definition for rarefaction. Question 23. The top row of bars represent a set of particles inside the Earth and at rest. The question is, what should be measured to determine the amplitude of the oscillations of the particles in the lower row as the wave passes? Okay. We know that distance doesn't show amplitude. So B and D will be wrong, because distance shows wavelength, not amplitude. So you should think about A and C. You know that this is a complete wave and this is undisturbed position. So this axis is undisturbed position. So from undisturbed position to the maximum displacement is called amplitude. That's why C is right. The maximum displacement of the particles from their position at rest. At rest means undisturbed position. That's why C is right. Question 24. A straight tube is closed at one end and has a loudspeaker position at the open end. The frequency of the loudspeaker is initially very low and is increased slowly. A series of loudness maxima are heard. The stationary wave, which gives the first maximum, has a note at the closed end and an antinote at the open end. The frequency of the loudspeaker is F1 when the first maximum is heard. What is the frequency of the loudspeaker when the fourth maximum is heard? Okay, this is the air column tube. You can see that fundamental frequency is F0. So if you suppose length of the tube is L, so L is equal to lambda divided by 4, because distance from node to antinode is 1/4 lambda. Then you can find lambda, which is 4L. Then, according to this point, that for an air column closed at one end, frequency of each harmonic is an odd multiple of the fundamental frequency F0. So if fundamental frequency is F0, so 3F0 will be second harmonic, 5F0 will be third harmonic, and 7F0, 7 times F0 will be fourth harmonic. So we want in this question fourth harmonic, so 7F0 will be answered. So D is right. Question 25. A buzzer emitting sound of frequency 846 Hz is attached to a string and rotated in a horizontal circle. The linear speed of the buzzer is 25 meters per second. The speed of sound is 340 meters per second. What is the maximum frequency heard by the observer? You know that maximum frequency happens in this formula: observer frequency equal to Fs times V divided by V plus minus V of source. So if F is maximum, then denominator should be minimum. So you should use minus. So FO equal to Fs times V over V minus Vs. If you substitute numbers, 846 times 340 divided by 340 minus 25, you will get 913 Hertz. So D is right. Question 25, D is right. For question 26, the diagram shows the principal regions of the electromagnetic spectrum with some details labeled. The diagram is not to scale. What is the typical order of magnitude of the wavelength of the radiation in region Q? In this region, it is set at 10 to the power negative 10. So we know that nearly each region, range of each region is 10 to the power negative 2. So if you suppose this part become 10 to the power negative 8, 10 to the power negative 6, 10 to the power negative 4, 10 to the power negative 2, you can find answer. The second method is that you should memorize a range of different electromagnetic spectrum waves. For example, for microwave, you should memorize that. How much is that? It is something 1 centimeter to 0.1, 0.2, 0.01 centimeter. For X-ray, wavelength is 10 to the power negative 10 meter, nearly 10 to the power negative 10 meter. Then for each part you should memorize. So from radio wave to gamma ray, you should memorize the wavelength of each part. So for this question, C is right. Question 27. P and Q are fixed points at the end of the string. A transfer stationary wave of constant maximum amplitude is formed on the string. P, R, and Q are the only points on the string where notes are formed. S and T are 2 points on the string at a distance x from R. What is the relationship between points S and T? Okay. If 2 points are in either side of a node, they are antiphase. What does it mean? It means phase difference of them will be 180. So when S moves up by a certain displacement, T moves down by the same displacement. According to this, you can choose C. So this question, C is right. Question 28. Two identical diode speakers are connected in series to an AC supply as shown. A microphone is moved along the line PQ. Which graph best shows the variation with distance from P of the intensity of the sound detected by the microphone? First of all, B and D will be wrong. Why? Because intensity cannot be zero because of AC supply, which gives out sound continuously. So when sound comes continuously, intensity never be zero. That's why B and D will be wrong. The second point is that when you go further from middle of the PQ, intensity will decrease. Based on this, C also will be wrong. So A is the correct answer. And we know that maximum intensity will be in the middle of PQ. So in the middle of PQ, intensity will be maximum. Based on these reasons, you can choose A. Question 29. A diffraction grating experiment is set up using orange light of wavelength 600 nanometer. The grating has a slit separation of 2 micrometer. What is the angular separation between the first and second order maxima of the orange light? So you should find theta 2 minus theta 1. You know, for diffraction grating, n lambda equal to d sine theta. So sine theta will be n lambda divided by d. So theta will be sine inverse of n lambda divided by d. So now theta 2 minus theta 1 equal to sine inverse of 2 times 600 times 10 to the power negative 9 divided by d, which is 2 times 10 to the power negative 6, minus sine inverse of 1 times 600 times 10 to the power negative 9 divided by 2 times 10 to the power negative 6. This is second order and this is first order. So instead of second order you should write 2 because n is 2, and for first order you can write 1. If you calculate, the result will be 19.4 degree. So B is right. Question 30. Two horizontal parallel plate conductors are separated by a distance of 5 mm in air. The lower plate is earthed and the potential of the upper plate is 50 volt. What is the electric field strength at the point midway between the plates? We know that electric field strength equal to potential difference divided by distance between two plates. Potential difference is 50 and distance will be 5 millimeter, which is 5 times 10 to the power negative 3 meter. So the answer will be 10,000 volt per meter. So, and then now it is said the lower plate is earthed. When the lower plate is earthed, the upper plate has positive 50 volt and the lower plate is earthed, so it means voltage is 0. So we know that direction of electric field strength is from positive or larger voltage to lower voltage. So direction of electric field will be from up to down. So you can say downwards. That's why A is right. Question 30. A is right.